Hi, everyone. Thanks for showing up for your learning. We're going to walk through the Delta Math problems for today. We're going to start with some trigonometry word problems, and then move on to moving from standard to vertex form. So I'll show you a couple methods to do that and what these problems will look like. So when we're reading these problems, it's going to be very important that we can translate these numbers to a very clear diagram. So I'm going to open up some paper for myself and get as much clear paper as I can. Move that over and gather my numbers and transfer them over to the paper. All right, so first step is the angle of elevation. So I know that I'm going to have some kind of triangle, and it's going to be there's going to be an angle of elevation involved, 44 degrees, very close to 45 degrees. Okay, so here we go. Pion. Some kind of angle of elevation. I'm going to put that in there, 44 degrees. Remember, an angle of elevation is some kind of going above the horizon, looking up over the ground. So that's angle of elevation. How much do you have to look up? Okay, from a point on the ground, okay, here's a point on the ground. It's measured to be 44 degrees. How tall is the tree if the point on the ground is 51 feet from the tree? Okay, so we've got a tree here, and there's one and only one way to draw a tree, and that's with a triangle and a rectangle. There, that's a tree. And if you draw your tree some other way, I don't know if I can help you. Okay, so here, the top of the tree is there. I don't know how tall the tree is, but I want to find it. Call the height of the tree T. Sure. Okay, and then I know that this is 51 feet. Oh, wait, that's inches. 51 feet from the ground. If it was 51 inches, that would be a short tree. And this will make a 90-degree angle. So here is my triangle. There. 44 degrees, 51 degrees, 51 feet. Okay, so this triangle is going to be about 50.5 feet. That's my guess. Very close to 51. All right, so what do? Well, I am going to look at the trigonometric ratio that relates opposite the angle to the adjacent to the angle, and that is tangent. So tangent of 44 degrees is going to be equal to the opposite over the adjacent, 51. So then what I punch on my calculator is 51 multiplied by tan 44 equals t. Okay, let's do that. Don't be scared. It's just grade 11. Okay, so 51 times 44 tangent. The tangent of 44. There it is, 51 times tan 44. That's tan 44 equals, oh, I was wrong. I thought it was going to be above 50. It's 49.25. Very close to my estimate. How much accuracy do I need here? To the nearest hundredth of a foot, if necessary. So this is tenths, this is hundredths. So that's the nearest hundredth of a foot. Copy, paste. Hooray! Okay, so we want to remember this is an angle of depression, this is an angle of elevation, so that's how we draw our diagram. They draw the diagram, the tree in the correct way, a triangle with a rectangle. Joking. You can draw your trees artistically and beautifully if you so choose. And then they related it with tangent, opposite over adjacent. Beautiful. Let's take a look at more questions. From the observation deck of a skyscraper, Jamal, oh, there you are, Jamal. Jamal measures a 45-degree angle of depression to a ship in the harbor below. The observation deck is 914 feet high. What's the horizontal distance from the base of skyscraper out to the ship? Okay. So let's get ourselves some fresh paper. Fresh paper. There we go. Move this over here. So we are looking down from the observation deck of a skyscraper. So let's just draw our skyscraper here. There's one way to draw that. It's a rectangle with squares in it with crosses on them. That's the only way to draw a skyscraper. It's a mathematically correct way. Right? And then you draw yourself, and the mathematically correct way is a stick figure. And you notice that when you look out from the horizon and then shift your eyes down at an angle of 45 degrees to a ship in the harbor below. And there's one way to draw that. It's with a semicircle. with a triangle on top like that. So that's a ship. Okay. Now we know that the observation deck is 914 feet high. So we can draw this triangle here. Okay. This is 914 feet. And because Delta Math is American, we're working in feet instead of meters. Okay, so here, this is also 914. Okay, was the horizontal distance of the base of the skyscraper out to the ship. So we've been asked to find this distance, which will be the same as that distance. So I can actually flip this triangle around. This would be 90 degrees. This would be 45 degrees. This is 45 degrees. If this is 914, then that's 914, and then that's also 914. Why? Because 45 degrees creates an isosceles triangle. Well, let's pretend we didn't know that. We would write this down. Here we have opposite and adjacent, and we want to find this one, A. It's the horizontal distance. This is the opposite. Here's our right angle. So this is, again, opposite that side. So tangent of 45 degrees is 1, but we're going to find that out in a second, is equal to 914 over opposite over adjacent, right? Okay, cool. All right, now let's do our bedmas to solve that. Okay, let's just check and see in our calculator what tan of 45 is. Clear everything, write 45 degrees, take the tangent of it. Oh, it's 1, because it's an isosceles triangle, right? Isosceles means the two sides are the same length. 45 degrees, 45 degrees, 90. Notice that adds up to 180. Okay, so these two angles have to be the same in a 45-degree triangle. Okay, another way of looking at it. All right, why am I giving you so many ways of looking at it? Because you want to understand the connections between ideas. Here's a square. Okay, the corner of a square is 90 degrees. Suppose I cut the square in half. Then this is 90 degrees cut in half is 45 on either corner. It's just so straightforward. I don't know why they're asking this question. So anyway, if this is 1, then I know that this must divide by some number to equal 1. Anything divided by itself is 1. So this A is 914. They're the same. That the ratio is 1. But let's say we didn't know that. What I would do is I would multiply both sides by A and divide both sides by tan 45. This cancels. And then I divide by tan 45. So I'm putting that on the bottom of the fraction. And then I have this line, A, these cancel, of course, equals 914 divided by tan 45. And we've just found that tan 45 is 1, so A is equal to 914. See, I take my time and show you all of the different ways around these questions when I can just do that in my head, just like instantly, just copy down the number. Yay! Okay, let's see if they do trig. Oh, draw a diagram. Okay, so there's their diagram. Much more beautiful than mine. Identify opposite adjacent hypotenuse. They're actually doing it. They're actually doing tan 45. Okay, so they call this cross multiply, pion, which is fine. I multiply both sides by x. It's the same. Okay, and then they divide both sides by tan 45. They say it's equal to 914, and then they say it's approximately equal to 914. That's weird. It's like saying, I'm 42 years old, or approximately 42 years old. Why would I say that? Anyway, another question. You want to do lots of these. Okay, so we're still on top of a skyscraper. We're going to draw a more beautiful diagram with a mathematically correct skyscraper. And here's what it looks like. Okay, so Isabella is there. She is on top of a skyscraper. Okay. Here she is. Very big building with big windows. She has a very long neck. Okay, she measures a 67-degree angle of depression. So 67 degrees, very steep, nearly 90. Well, not quite, but close enough. If the observation deck is 824 feet high. So And we're assuming that these ships here are right at the ground level, like that. Okay, so this is a right angle because it's height and horizontal. So it's necessarily right angle. This is 824 feet, and this is 67 degrees. So find out how far the distance is. Again, we're going to be using tangent because we want to find this here. The adjacent and opposite relates to adjacent through tangent. SOHCAHTOA. So I say tan 67 degrees is equal to 824 over A. Why? Tangent is opposite over adjacent. Got to put them in the right order over there. It does not work. All right. Now, some of you use this method. The A comes up here, and the tan comes down here. And that's okay, as long as you know why. You're multiplying by A, and then you're dividing by tan 67. So we get A is equal to 824 divided by tan 67. Okay, let's take a look at it. Clear. 824 divided by 67 tangent. I don't know why it doesn't allow me to just type it that way. Anyway, so this is the value of tangent for 67 degrees. All right, meaning this side is going to be 2.4, about 2.35585, times as long as that side. So when I divide this by this, I will get this. 349.767. Okay, so
Mr. Jennings.
See what they are looking for there. One moment. All right, let's see, where were we? So we were talking about this. We need to solve this equation. Have I solved it yet? 864 divided by tan 65. Yeah, it's this. And I just need to know what level of detail. Nearest tenth of a foot. Okay, so I'm going to look at this. And that's the nearest tenth of a foot. But this number here makes that number round up. So it's this here. Oh, geez. Come on. Oh, come on. Oh, let me select. Would have been faster to just type it, wouldn't it have? I type this in, but I don't forget to round. And I submit answer, and I say yes, yay! And so then you look and you see, okay, look at how beautiful their diagram is. But they're not drawing skyscrapers in the mathematically correct form. Okay, that's a joke. All right, let's find one that's not tangent. Horizontal distance, no, that's still tangent from a hot air balloon. Still tangent. Geez, will they give me one that's not tangent, I wonder? Oh man, why would they do that? Why would they have three ratios they could choose from and only use one of them? Oh man. Vertical distance. Why don't they say what's the real distance? Like the actual distance between the thing. So anyway, if you can use tangent, you can do all of these questions. All right, a little disappointing. Now, let's take a look at standard to vertex form. Okay, so these are more algebraically fun. All right, so here we go. We want to rewrite this quadratic function in vertex form. I'm going to show you there's two ways to do it. No, there's a bunch of ways to do it. I'll show you a couple. Okay, the first is complete the square. So to complete the square, let's write it out. Y equals x squared minus x plus 7. Oh, plus y, what are you doing? 7. Okay. To complete the square, what I do is I look at this number b. Well, first I factor out a. This set of problems is only going to give you a is equal to 1, so it's a little easier than what we're doing tomorrow. So you don't have to do this step. Next, you look at b, and you say, well, what's negative b over 2 squared? Wait, is b over 2 squared? I'm a little rusty on my completing the square. I think it's negative b over 2. Negative b over 2? Wait. Whoa, I'm going to pause the video and like get my head. Yeah. It's just b over 2. You don't need negative b over 2. Just use b over 2 squared. And so then I get, this is negative 1. So negative 1 divided by 2 is negative 1 half. Negative 1 half times negative 1 half is 1 quarter. Okay, I'll just write it out. This is negative 1 over 2 squared equals 1 quarter. So this is the Jerry Maguire number that will complete the square here. So let's write it out. Y equals x squared minus x plus 1 over 4 minus 1 over 4 plus 7. Okay, so now I can see that this section here, we'll circle it with a rainbow pen, very exciting. This section here is a perfect square trinomial. And what is it? Well, it's y equals x minus 1 half squared. This number here, negative 1 half squared, minus 1 quarter plus 7. These two things over here are what's going to be my k term over there. So minus a quarter plus 7, that is plus 6 3/4. Okay, what's 6 3/4? Well, let's write it as an improper fraction, as a little nicer. Y equals x minus 1 half, all squared, plus 6 times 4 is 24. 24 plus 3 is 27 over 4. If you're confused, check these two values on your calculator and see that they're the same. Okay? And the way you do that is you do 6 times 4 is 24, and then you add it to this. Because this would be 6 plus 3/4. 6 can also be written as 24 over 4. Then you add 24 over 4 to 3 over 4. All right, maybe I shouldn't stick my tongue out at you. Okay, so x minus a half squared plus 27 over 4. You write that in. X minus 1 over 2 squared plus 27 over 4. Yay! Now let's see what they do. B is negative 1. See, they get that there. This is negative 1. They don't write the 1. Okay, but it is negative 1. Is negative 1 apple there? Negative 1 x. Determine b squared. They convert to decimals for some ungodly reason. You can too if you want. They added and they subtracted. The same thing I did. I added a quarter and subtracted a quarter. And then they got plus 6.75. And then my answer is more beautiful than theirs. Delta math. Okay, new question. Is that the same question? It basically is. I'll do this one in my head. This is going to be x minus 1 over 2 squared minus 1 is 5/4. How do I know this? We just completed the square for another one that had a b of minus 1. So instead of adding 7 to the negative quarter that pops out here, I subtracted 1 from the negative quarter. That gave me negative 5/4. So I could very quickly do that one in my head. All right, let's take a look at another one. This is better. So let's do this one in our heads. Half of 10 is 5. 5 squared is 25. So I will have x plus 5 squared in the brackets. And then a negative 25 is going to pop out. So I'm going to have minus 27. Hooray. Okay, let's take a look at it. What if I use the, I'm just going to get this done graphically method. And I just open a Desmos, a fresh Desmos without creepy looking squiggles. And I say y is equal to x squared plus 10x. So here it is, minus or plus or something, minus 2. Okay, minus 2. Minus 2. So we'll see this one won't have nice roots. See, it's got a root there, which is rational or radical. And then it's got a vertex well down here. We know that the vertex is here at minus 5. Okay, so it's way down here at x is minus 5. And the value is in the minus 27. So that's the vertex. Okay, now let's take a look here. I just was able to just look at it and tell you x, if x is minus 5, then this would be 0, and the value of y would be negative 27. Okay, so when x is negative 5. That's why this one is a sign flipper. But otherwise, the 5 and the minus 27 give you the coordinates of the vertex. Now, let's try this one a different way if we didn't want to use completing the square like we've looked at. What we could use is what we did yesterday, finding the axis of symmetry and then using that to calculate the vertex. We're going to write out our function here. Y is equal to x squared minus 10x plus 10x, Mr. Jennings, minus 2. Okay, now I use negative b over 2a to find the axis of symmetry. That's equal to negative 10 over 2 times 1. So that's negative 10 over 2. That's equal to negative 5. Notice that that has given us the x value of the vertex. If I graph the line x equals negative 5, that is the axis of symmetry for this parabola. The axis of symmetry passes through the vertex. Now, carrying on. So now that we've got the negative 5, then we just substitute it in. Y is equal to negative 5 squared. What's this? Plus 10 times negative 5. That's this term. Minus 2. Okay? Now, y is equal to, this is 25, positive 25. This is negative 50. 10 times negative 5, negative 50. This is minus 2. 25 minus 50 is minus 25. Minus 25 minus 2, minus 27. So this number and this number go together to give us the vertex. Okay. Now, if that's what we've got, we now know that this is a parabola. This is, I'll show you what we know already. This is a parabola. Here's its stretch factor. Is equal to 1, because that's an a is equal to 1 there. It's not 0. If that was 0, you would not see this term. Anything multiplied by 0, we don't write down. I'm 42 plus 80 times 0 years old. I don't usually write down the plus 80 times 0 part. Okay, now, I know it has a stretch factor of 1, and it has a vertex at negative 5, negative 27. Okay, usually where I write down the vertex is HK. This is like the letters we use for the vertex. These numbers came from negative b over 2a, and then taking negative b over 2a and substituting it in to the function, to the quadratic, to solve for what y is when x equals 5. Now, what I know are the three numbers that show up in the format for vertex form. You'll recall it's y is equal to a multiplied by x minus h squared plus k, where hk is the vertex. This is our form. So just input those values. Y is equal to 1 times x minus minus 5. Another way of saying minus minus 5 is saying plus 5 squared plus k. Well, plus a negative number is minus 27. And this is what we wrote down as our answer because we're not maniacs and we don't write down the multiply by 1. Let's do one more. Okay, x squared minus 2x minus 2. So let's do it in our heads first. Minus 2 over 2 is minus 1. Minus 1 squared is 1. So my Jerry Maguire number that will complete this square is 1. So I'm going to add and subtract 1 from this equation. So I'm going to get, this is x minus 1. That was, oh, and it's not 9x minus 1. That's a bracket, Mr. Jennings. No, don't put the cheese. Thank you, Delta Math, for all of your help. No thank you, Delta Math. Squared. Okay, x minus 1 squared, so half of that squared. And then I had to add another minus 1, so minus 3. Yay, let's do this one by completing the square this time. Do it both ways, because it's a really easy example. It's really simple numbers that will allow us to see the ease with which we can approach both solutions. One is completing the square. Y is equal to x squared minus 2x minus 2. I take minus 2 to the side and divide it by 2 and square it. That gives me negative 1 squared. That gives me 1. Okay, so I'm going to add and subtract 1 from this. Y is equal to x squared minus 2x plus 1 minus 1 minus 2. If I bracket this, this is a perfect square trinomial. It is equal to y is equal to x minus 1 squared minus 3. That's completing the square. Now let's use negative b over 2a, another method. Okay, this one I take negative b, which is negative 2. So negative b over 2a is equal to negative 2. So that's just 2 over 2 because a is 1. And that's equal to 1. 2 divided by 2 is 1. You heard it here first. All right, so now I know that this is the axis of symmetry. So I'm already starting to build a picture of my parabola. Here is the line x equals 1, and the vertex lies somewhere down there. Okay. So let's evaluate what the vertex is. I bet it's at minus 3. Okay, this will actually be a little lower down, this parabola that I drew. It's like this. Okay. All right, it's not that one. So anyway, how do I know? Well, this is the C gives me the y-intercept. So the y-intercept's already down there at minus 2. And a parabola that could go through that and turn around there might be given by this function formula here. All right. So, okay. Now I know that this is x equals 1, this line. So now I just need to know what's the value of the function, what's the y value when x equals 1. Let's substitute it in. Y equals this formula here, 1 squared. Sorry, x is minus 1. No, when x is 1. Jeez, x is 1. So when x is 1, not minus 1. They don't flip the sign there. You know that the axis of symmetry is when x is 1. So when x is 1, not minus 1. When x is 1, you get a vertex. Okay, cool. So 1 squared minus 2 times 1 minus 2. Well, let's do that. 1 squared is 1. Negative 2 times 1 is negative 2. 1 minus 2 is minus 1. Minus 1 minus another 2 is minus 3. So we've got the y value and the x value of the vertex. So now all I need to do is write out y is equal to a is 1, so I don't write anything there. X minus this. That's where you flip the sign inside this form. X minus 1 squared minus 3. Also the answer. Okay, that's all the examples I'm going to show you of that. Tomorrow we'll do a review lesson for completing the square when a is not 1. And those are all of our quadratic skills, at least the algebraic ones. We'll get a little bit more practice solving word problems with quadratics when we get back together for that final week. Okay, bye for now, everybody.